Hello people and welcome back to Maybe a Smile. In this session we will be continuing with ratio and proportion. This is the second episode, and if you haven't watched the first episode, I would really recommend you to go and watch that one first, because in that we discussed a lots of basic concepts and we also did a few basic questions. Over here we will be doing a few more questions which are on a slightly higher level. And before doing that, let me just quickly go through the properties of proportions. Okay, so the first thing that we know, that a proportion is basically when A upon B is equal to C upon D. These two ratios are equal, only then it is called as a proportion. Okay, now I will not discuss invertendo and alternando because we know that is very simple. We'll just discuss what componendo is. Now componendo is basically numerator plus denominator upon the denominator. So it is A plus B upon B is equal to C plus D upon D. Now I'm going through it very quickly because we have already discussed this in the first one. Now dividendo is basically numerator minus the denominator upon denominator. So A minus B upon B is equal to C minus D upon D. And lastly we have componendo dividendo, which is the division of these two. So A plus B upon A minus B is equal to C plus D upon C minus D. That is componendo dividendo. Okay, let us move to the first question. Actually it is the 9th question because we have done 8 questions in the first episode. Okay, so here it says if 3a plus 4b times 3c minus 4d is equal to 3a minus 4b times 3c plus 4d, I have to prove that a is to b is equal to c is to d. Okay, firstly I would write this thing as 3a plus 4b upon 3a minus 4b. Why do I do this? Because I want all the a's and b's on one side and I want all the c's and d's on the other side. Okay, so this 3c plus 4d remains there, and the 3c minus 4d from here goes to the denominator and it becomes 3c minus 4d. Now I'll be using componendo dividendo over here. Okay, so I'll write by cd. In the examination obviously you have to write by componendo dividendo completely. Okay, now componendo dividendo says numerator plus denominator upon numerator minus the denominator. Okay, so this is 3a plus 4b, that's the numerator, plus the denominator which is 3a minus 4b upon numerator minus the denominator. So 3a plus 4b numerator minus the denominator which is 3a minus 4b. Now obviously this is wrong because since there is a minus sign over here, I need to put up a bracket. This bracket is super important. Okay, same thing happens on the right hand side. So 3c plus 4d plus 3c minus 4d, the whole thing upon 3c plus 4d minus, and then obviously I'll put up a bracket and it would be 3c minus 4d. Okay, let us try to simplify the brackets and see what happens. In the numerator I can see that the 4b and the negative 4b just cancelled out. I am left with 3a plus 3a, which is 6a. In the denominator, when I open up these brackets, it becomes 3a plus 4b minus 3a, minus and minus is a plus 4b is equal to, on the right hand side I can see 4d and negative 4d just goes away. 3c plus 3c is 6c, and in the denominator again it would be a similar thing, 3c plus 4d minus 3c plus 4d. Okay, on both the sides the 3a negative 3a goes away, and over here 3c and negative 3c just goes away. I am left with 6a upon 4b plus 4b is 8b is equal to 6c upon 4d plus 4d is 8d. I can cancel out the numbers, so 6 and 6 goes away, 8 and 8 goes away, and I am finally left with a upon b is equal to c upon d, which can obviously be written in the ratio format also. Okay, that was an easy question. Okay, so let's do this question. So here it says if x is equal to 6ab upon a plus b, I need to find the value of x plus 3a upon x minus 3a, and it's not an equal to sign, there is an error there, it should be plus x plus 3b upon x minus 3b. The first way of doing this question is actually substituting the value of x as 6ab upon a plus b in the entire expression and solving it completely. The other way which I like to do is actually writing it as x is equal to 6 can be written as 3 times 2 times a and b, and then in the denominator it is a plus b as it is. The first time I'll take the 3 and the a to the denominator and I'll make it as x upon 3a is equal to 2b upon a plus b. So from this numerator I just took the 3a because there is a 3a over here. The second time I would do a similar kind of thing, which is I'll take x upon 3b because I need a 3b over here in the second term of that expression is equal to, I'm left with 2a upon a plus b. Okay, now these are equations which are formed as per the requirement of the answer. what do? I just do componendo dividendo in both of these. So by componendo dividendo, okay, componendo dividendo is numerator plus denominator upon numerator minus the denominator. So it becomes x plus 3a upon x minus 3a is equal to 2b plus a plus b upon 2b, and then I have to subtract it, so it becomes minus a minus b. So this eventually becomes 2b plus b is 3b plus a, and in the denominator 2b minus b is just b minus the a, and this is the value of x plus 3a upon x minus 3a. Okay, on the other thing which is over here, I'll have to do the same thing. So it becomes x plus 3b upon x minus 3b is equal to 2a plus a plus b upon 2a minus a minus b, and x plus 3b upon x minus 3b would be equal to 2a plus a is 3a plus b. In the denominator, 2a minus a is just a and then minus b. Now if you look very closely over here, you got x plus 3a upon x minus 3a, which is this thing, and you also got x plus 3b upon x minus 3b, which is this thing. We basically need to add both of these things. What do I need to add? I need to add this and this. So let us take it to the other page. So this is 3b plus a upon b minus a. So 3b plus a upon b minus a plus 3a plus b upon a minus b, 3a plus b upon a minus b. Now these are not like fractions because the denominators of both the fractions are different. Now in order to make them like fractions, I'll have to factor out a minus sign from the second one I would do it. So this is 3b plus a upon b minus a plus 3a plus b upon, if I factor out a negative sign, it becomes b minus a, and this can be written as 3b plus a upon b minus a. These two would combine and become a negative, and then 3a plus b upon b minus a. Now both the denominators are same and I can combine the numerators. So it becomes 3b plus a, and then the minus sign goes to both of them. So it is minus 3a minus b upon b minus a. Okay, now 3b minus the b at the end becomes 2b. A minus 3a is negative 2a, and in the denominator I have b minus a. I can factor out a 2 from the numerator. I'd be left with b minus a, and the denominator also has a b minus a. We can just cancel out both of these, and my final answer is just 2. Okay, I would say if you really want to, or if you are just curious, you can substitute the value of x in the expression and try how long it goes, and probably you will see that method in your textbook also. It is surely there in the concise textbook if you follow that book. If not, then you can just try doing it, and I prefer this method. Okay, let us move ahead to the next question. Here it is a similar question. It says if a is equal to 4 root 6 upon 2 root 2 plus root 3, I need to find the value of this entire expression. Now this is a similar kind of question. Let us see how it works. Okay, so a is actually not 4 root 6, it is 2 times 2. The root 6 can be written as root 2 times root 3, and the denominator stays how it is, which is root 2 plus root 3, root 2 plus the root 3. Okay, now I can see a 2 root 2 and I can see a 2 root 3. So once I'll take a 2 root 2 down, and the other time I'll take a 2 root 3 down. So it becomes a upon 2 root 2 is equal to 2 root 3 upon root 2 plus root 3. And the next time I would take a 2 root 3 down, so it becomes a upon 2 root 3 is equal to 2 root 2 upon root 2 plus root 3. Now this time I would again do componendo and dividendo, so it becomes by componendo dividendo. It is a plus 2 root 2 upon a minus 2 root 2 is equal to 2 root 3 plus root 2 plus root 3, and the denominator would be 2 root 3 minus root 2 minus root 3. When I simplify this thing, I'll get a plus 2 root 2 upon a minus 2 root 2 is equal to 2 root 3 plus the root 3 at the end becomes 3 root 3 plus root 2, and the denominator is 2 root 3 minus root 3 is just root 3 minus the root 2. That is the first part. Now in the second part I would do the same exact thing. So it becomes a plus 2 root 3 upon a minus 2 root 3 is equal to 2 root 2 plus root 2 plus root 3, and in the denominator it would get subtracted. So 2 root 2 minus root 2 minus root 3. So a plus 2 root 3 upon a minus 2 root 3, a minus 2 root 3 would be equal to 2 root 2 plus root 2 is 3 root 2 plus the root 3. In the denominator, 2 root 2 minus root 2 is just root 2 and then minus the root 3. Now if I see very closely, a plus 2 root 2 upon a minus 2 root 2 is exactly over here, and the second one, which is a plus 2 root 3 upon a minus 2 root 3, is exactly over here, which means I need to add this and this. So when I add the left hand side of both these equations, that would be my question, the expression that is given, and the right hand side would be my answers. So let us just copy it down to the next page. So 3 root 3 plus root 2, 3 root 3 plus root 2 upon root 3 minus root 2. I hope I have written that correct. Root 3 minus root 2. Okay. The next one is 3 root 2 plus root 3. 3 root 2 plus root 3 upon, I suppose it is root 2 minus root 3. Okay. So it is root 2 minus the root 3. Okay. Now again it's the same kind of problem. We need to factor out a minus sign so that it becomes a like fraction. So it is 3 root 3 plus root 2 upon root 3 minus root 2. This becomes a minus, and it is 3 root 2 plus root 3, and in the denominator I will be left with root 3 minus root 2. Now these are like fractions. I can combine the numerators of both these. So it becomes 3 root 3 plus root 2. The minus sign shows an effect on both of them. So negative 3 root 2 and negative root 3, and the denominator stays the same, which is root 3 minus root 2. Now let's see what cancels out. So 3 root 3 minus the root 3 at the end becomes 2 root 3. Root 2 minus 3 root 2 is negative 2 root 2, and the denominator is root 3 minus root 2. I can factor out a 2 from the numerator. It is root 3 minus root 2, and the denominator is again root 3 minus root 2. Cancel out these two things, and my final answer is again 2 as the previous question. Okay, let us move ahead to the next question. Now this one says if a minus all of these things, I just need to prove a very small thing, which is 2AD is equal to 3BC. I just need to prove that. Now this is a very huge thing that is given to me. Do not be worried about that. You just have to use componendo dividendo. Okay, so by componendo dividendo, it means I have to do numerator plus denominator upon numerator minus denominator. Look very carefully. This becomes a minus 2b minus 3c plus 4d, that's the numerator, plus the denominator, which is a plus 2b minus 3c minus 4d, numerator plus the denominator, upon numerator minus the denominator. So I write the entire numerator as it is. So a minus 2b minus 3c plus 4d minus the entire denominator, which means everybody would get a negative sign. So minus a minus 2b plus 3c plus 4d, and that should be equal to everything, the same exact thing on the right hand side also, numerator plus denominator. So a minus 2b plus 3c minus 4d, that's the numerator, plus the denominator, which is a plus 2b plus 3c plus 4d, and the denominator would be numerator, which is a minus 2b plus 3c minus 4d minus the denominator, which means everybody gets a negative sign. So minus a minus 2b minus 3c minus 4d. Now let's see if I can simplify this thing. So I can see a negative 2b and a positive 2b can go away. I can see a 4d and a negative 4d go away. In the denominator, the a and the negative a can go away, and the negative 3c and the positive 3c can go away. What am I left with? I'm left with a plus a, which is 2a, and negative 3c is negative 6c. In the denominator, I am left with negative 2b is negative 4b, and 4d plus 4d is just 8d is equal to, let's see, over here I can get rid of the negative 2b and positive 2b. I can get rid of the negative 4d and positive 4d. Over here in the denominator, a minus a goes away, 3c and minus 3c can go away. I'm left with a plus a, which is 2a, 3c plus 3c is 6c. In the denominator, minus 2b is minus 4b, and minus 4d and minus 4d is minus 8d. Okay, what do I do? I need to keep all the a's and b's on one side, and I mean a's and c's on one side and b's and d's on the other side. Okay, so I just send the 2a and 6c from the right hand side to the left hand side. So it becomes 2a minus 6c upon 2a plus 6c is equal to these things, the negative 4d and the 8d goes to the other side. So negative 4b plus 8d, and in the denominator it is negative 4b minus 8d. Okay, I'll again use componendo dividendo. Okay, so by componendo dividendo, it is numerator plus the denominator. So 2a minus 6c plus 2a plus 6c. In the denominator, it is numerator minus the denominator. So it would be 2a minus 6c, and everybody would get a negative sign. So minus 2a minus 6c is equal to, same thing over here, numerator plus the denominator. So minus 4b plus 8d minus 4b minus 8d, and the denominator would be numerator, which is minus 4b plus 8d minus the denominator. So everybody gets a negative sign, so they become positive. So plus 4b plus 8d. Okay, let's see what cancels out. Over here, the negative and the positive 6c's can go away. 2a negative 2a just goes away. 8d negative 8d goes away. Negative 4b positive 4b goes away. Okay, I think I have some space over here, so I'll write it over there. So 2a plus 2a is just a 4a. In the denominator, I have negative 6c, and negative 6c is negative 12c is equal to, right hand side it becomes negative 8b, and upon the denominator is 16d. Okay, let us try to simplify all of this. So 4 times 1 and 4 times 3 and 8 times 1 and 8 times 2. So the 2d can go to the other side, so it becomes 2ad is equal to, this 3c can go to the other side and it becomes negative, it is actually a negative 3c times negative b. So 2ad is equal to 3bc, and that is exactly what is required in the question. Okay, let us move ahead. Okay, we had an empty space. Okay, this is the question. Now this question says, using properties of proportion, solve for x. So I need to solve the value, I need to find the value of x, but I have to use the properties of proportion, because if I follow any other method, that would just be so long. Okay, what do I do? Absolutely nothing. Componendo dividendo, very easy. Okay, so by componendo dividendo, this becomes root of x plus 5 plus root of x minus 16 plus root of x plus 5 minus root of x minus 16. In the denominator, so here I just did numerator plus the denominator, now I will do numerator minus the denominator. So root of x plus 5 plus root of x minus 16 minus root of x plus 5, and minus becomes a plus root of x plus 16. I mean it is x minus 16, sorry, yeah, x minus 16 is equal to, same thing, 7 plus 3 upon 7 minus 3. In the numerator, these two roots can just go away. In the denominator, these two roots go away. Now root of x plus 5 plus root of x plus 5 is actually 2 times root of x plus 5. In the denominator, root of x minus 16 and root of x minus 16 is 2 times root of x minus 16 is equal to, 7 plus 3 is 10, 7 minus 3 is just 4. The 2 and the 2 goes away, 2 times 2 is 4, 2 times 5 is 10. Okay, now what do? I just send the 2 to the other side, so it becomes 2 root of x plus 5 is equal to 5 root of x minus 16. Now I would square on both the sides. Okay, if I square on both the sides, it becomes 4, and then the square root goes away and it becomes x plus 5 is equal to, 5 square is 25, square root goes away, x minus 16. Let us take it to the next page. So it becomes 4x plus 20 is equal to 25 times x minus 16. Okay, so 25x minus, now 25 times 16 is actually 25 times 4 times 4. 25 times 4 is 100, 100 times 4 is 400. Okay, all the x's on one side, everything that does not have an x goes to the other side. So 20 plus 400 is equal to 25x minus the 4x. This becomes 420 is equal to 21x. We can cancel it out, 21 times 1, 21 times 2 and 0. X would be equal to 20, and that is it. Let us move ahead to the next question. This thing again says the same thing. Using properties of proportion, I need to solve for x. Same thing by componendo dividendo. Okay, so numerator plus the denominator. So 3x plus root of 9x square minus 5 plus 3x minus root of 9x square minus 5, and the denominator would become numerator minus the denominator. So 3x plus root of 9x square minus 5 minus 3x, and it becomes a plus root of 9x square minus 5. Now the thing is, what happens to the right hand side? Because there is no fraction. Actually there is a fraction. This 5 is actually 5 upon 1. So I can write it as 5 plus 1 upon 5 minus 1. How easy. In the numerator, both the square root terms go away. In the denominator, the 3x and the negative 3x goes away. So 3x plus 3x is a 6x, and in the denominator, root of 9x square minus 5 plus another root of 9x square minus 5 is twice root of 9x square minus 5 is equal to 6 upon 4. The 6 can go away from both the sides, 2 times 1 and 2 times 2. Okay, the 2 goes to the numerator, the root goes to the numerator, so it becomes 2x is equal to root of 9x square minus 5. I don't need this square root, so I'll have to square on both the sides. When I square on both the sides, this thing becomes 4x square is equal to, the square root just go away, so 9x square minus 5. I'll just complete it over here. All the x's on one side, everything that does not have an x goes to the other side. So negative 5 comes to this side and becomes positive 5, and that would be equal to 9x square minus 4x square. So 5 is equal to 5x square. 5 and 5 just goes away, and x square would be equal to 1, and if x square is equal to 1, x would be plus or minus 1, and that is your answer. Next question. This one says, using properties of proportion, again solve for x. Same kind of question. Let's do componendo dividendo. So by componendo dividendo, this thing becomes x raised to 4 plus 1 plus 2x square. In the denominator, it would become x raised to 4 plus 1 minus 2x square is equal to 17 plus 8 upon 17 minus 8. Okay, can I just rearrange it in a specific order and write it as x raised to 4 plus 2x square plus 1. I'm writing it this way because I want it to be in reducing powers. Okay, so x raised to 4 minus 2x square plus 1 is equal to 17 plus 8 is 25, and in the denominator 17 minus 8 is just a 9. Now if you have a vision, you would be able to see something on the left hand side. This one is actually 1 square, and this one is actually also 1 square, and this thing is x square plus 1 the whole square, and in the denominator it is x square minus 1 the whole square. It is actually a complete square, and if you don't believe me, just open up the bracket a plus b the whole square. You'll exactly land into the previous step. Okay, now I have squares on everything. The first bracket, the denominator's bracket, and the right hand sides are also actually squares. If I just wish to write it as squares, I would write them as 5 square upon 3 squared, which means I can take a square root on both the sides. So this thing becomes x square plus 1 upon x square minus 1 is equal to 5 over 3. For time being, I am just ignoring that it could be positive and negative. I'm just considering the positive thing and solving it. The 3 goes to the other side, the x square minus 1 goes to the other side. So it is 3 times x square plus 1 is equal to 5 times x square minus 1. Opening up the brackets, 3x square plus 3 is equal to 5x square minus 5. All the numbers on one side, variables on the other side. So 3 plus 5 is equal to 5x square minus 3x square. 3 plus 5 is 8 is equal to 2x square. 2 times 1 and 2 times 4. So x square is equal to 4, which means x would be equal to plus or minus 2, and that is my answer. Okay, next question. It says, using properties of proportion, I need to solve for x. Okay, same thing again by componendo dividendo. This thing is k raised to 5 plus x raised to 5 plus x raised to 5 minus k raised to 5, and in the denominator it would be k raised to 5 plus x raised to 5 and minus the denominator, so minus x raised to 5 plus k raised to 5 is equal to 122 plus 121, and in the denominator it would be 122 minus 121. In the numerator, the positive and negative k raised to 5 goes away. In the denominator, the positive and negative x raised to 5 goes away. So I'd be left with 2 times x raised to 5 upon 2 times k raised to 5 is equal to, this would just become 243 upon 1. The 2 and the 2 goes away and I'm left with x raised to 5 is equal to 243 k raised to 5. Now I know that 243 is actually 3 raised to 5, so I can write it as x raised to 5 is equal to 3 raised to 5 times k raised to 5. I can take a fifth root on both the sides, so it becomes x is equal to 3k, and that is it. That is my answer. X is equal to 3k. Simple. Okay, let us move ahead to the next question. It says if x is equal to all of these things, I have to prove that thing. Okay, again, this is the kind of question where you need to use the given condition, that is x is equal to something, and I have to prove something else. Okay, I'll start with using componendo dividendo. Now if you have observed, majority of the questions are getting solved just by using componendo and dividendo. Okay, that's a very good property that we have over here. Okay, now this x is actually x upon 1, so it becomes x plus 1 upon x minus 1 is equal to, again on the right side, numerator plus denominator upon numerator minus the denominator. Okay, so if I add the numerator with the denominator, it becomes root of a plus 3b plus root of a minus 3b plus root of a plus 3b minus root of a minus 3b, and in the denominator it would be numerator minus the denominator, so root of a plus 3b plus root of a minus 3b, both of them get a negative sign, so negative root of a plus 3b plus root of a minus 3b. Okay, let's see what cancels out. So this and this term goes away, this one and this one just go away. So I'm left with x plus 1 upon x minus 1 is equal to root of a plus 3b plus root of a plus 3b is twice root of a plus 3b. In the denominator, root of a minus 3b and root of a minus 3b is actually twice root of a minus 3b. The 2 and the 2 just go away and I'm left with all of these things. Now if I look at my answer, it says I need the square of x, which means obviously I have to square on both the sides. So we'll do squaring both the sides. So it becomes x plus 1 upon x minus 1 all squared is equal to, on the right hand side just the square roots go away, so it is a plus 3b upon a minus 3b. Okay, let us expand the bracket. A plus b the whole square, a plus b the whole square is a square plus 2ab plus b square, and in the denominator it is a minus b the whole square, so x square minus 2x plus 1 is equal to a plus 3b upon a minus 3b. Now all of these things I can just paste it on the other page and I can use componendo dividendo. Let's just do that very quickly. This thing, let us copy it. Okay, there you go. I'll use componendo dividendo over here because I see similar terms. So by componendo dividendo, this becomes numerator plus denominator, so it is x square plus 2x plus 1 plus x square minus 2x plus 1 upon numerator minus the denominator, so it is x square plus 2x plus 1 minus the denominator, so everybody gets a negative sign, so minus x square plus 2x minus 1 is equal to, same thing on the right hand side, so a plus 3b plus a minus 3b upon a plus 3b minus a plus 3b. Let's see what goes away. So 2x and negative 2x goes away, x square and negative x square, 1 and negative 1 go away, 3b, negative 3b, a and negative a just goes away. X square plus x square is 2x square, 1 plus 1 is a 2. In the denominator I'll be left with a 4x is equal to a plus a is a 2a. In the denominator 3b plus 3b is 6b. Let us simplify this thing. 2 times 1 and 2 times 3 is this thing. I can factor out a 2 from here, so I'll be left with x square plus 1. In the denominator I'm left with 4x is equal to a over 3b. So 2 times 1 and 2 times 2, just get rid of the denominator. So 3b gets multiplied with x square plus 1 and it is equal to a times 2x. Opening up the bracket, so it becomes 3bx square plus 3b is equal to 2ax. I'll get this 2ax to the other side, so it becomes 3bx square minus 2ax plus 3b is equal to 0, and this is exactly what was required in the question. Okay, let us move ahead to the next question, and now it says if all of these equal to all of this, I have to show that nx is equal to my. Again, if it says if something something something, I have to use that given data and I have to prove a very small thing, which means again I have to use componendo and dividendo. Okay, so by componendo dividendo, this thing becomes numerator plus the denominator, so x cube plus 3xy square plus 3x square y plus y cube upon numerator minus the denominator, so x cube plus 3xy square minus 3x square y minus the y cube is equal to same thing on the right hand side. So m cube plus 3mn square plus 3m square n plus n cube, and in the denominator it would be numerator minus the denominator. So m cube plus 3mn square minus 3m square n minus the n cube. Now if you know the properties, that is the properties of algebra, which is a plus b the whole cube and a minus b the whole cube, those formulas, you can see that this is actually the expansion of those formulas. I'll just write the formulas over here. A plus b all cube is equal to a cube plus 3a square b plus 3ab square plus b cube, and if I have a negative sign over here, all the alternating terms would be negative. Okay, so my left hand side can now be written as x plus y the whole cube upon the denominator can be written as x minus y the whole cube is equal to, on the right hand side numerator becomes m plus n the whole cube upon the denominator becomes m minus n the whole cube. Now everybody is a cube, so I can take a cube root on both the sides, so it becomes x plus y upon x minus y is equal to m plus n upon m minus n. Okay, just get rid of the denominators, we'll cross multiply. So x plus y times m minus n is equal to, or shall I just use componendo? Yeah, I can just use componendo dividendo again. Okay, so by componendo dividendo, I could have done that thing also, this thing also works, doesn't really matter. Okay, I'll just do it here. So it is x plus y plus x minus y upon x plus y minus x plus y is equal to m plus n plus m minus n, and the denominator would be m plus n minus m plus n. Let's cancel out a few things. Y minus y, x and minus x goes away, n and minus n goes away, m and minus m goes away. So I'm left with x plus x, which is 2x upon y plus y is 2y is equal to 2m upon 2n. Get rid of all the 2's from both the sides and just send the n and y to the other side, so it becomes xn is equal to my, and that is what is exactly asked in the question. Okay, let us move ahead to the next question, and it says if x is equal to all of these things, I need to express n in terms of x and m. So basically it is supposed to be n is equal to something something something. On the right hand side it is supposed to be only x and m. Okay, to start with, this x is actually x upon 1, and using componendo dividendo again. Okay, now it becomes x plus 1 upon x minus 1 is equal to, now if I add, I won't be doing all the steps now because we've done enough questions. So when I add these two things, the m minus n, then m minus n in the roots just go away, and I'll be left with 2 times root of m plus n. And when I subtract these two, the first term, that is the m plus n and m plus n, just goes away, and I'll be left with 2 times root of m minus n. The 2 and the 2 goes away, and I'll square on both the sides because I need to get rid of the square root from there. So it becomes x plus 1 upon x minus 1 the whole square is equal to, roots go away, so m plus n upon m minus n. Here I can use a plus b the whole square and a minus b the whole square, which is a square plus 2ab plus b square, and the denominator would be a square minus 2ab plus b square is equal to m plus n upon m minus n. I'll again use componendo dividendo. So by componendo dividendo, this thing would now become x square plus 2x plus 1 plus x square minus 2x plus 1. In the denominator it is x square plus 2x plus 1 minus x square plus 2x minus 1 is equal to, same thing on the right hand side, so m plus n plus m minus n upon m plus n minus m plus n. Okay, let's cancel out a few things. So the 2x and the negative 2x, x square, negative x square, 1 and negative 1, n and negative n, m and negative m goes away. I'm left with x square plus x square is 2x square, 1 plus 1 is a 2. In the denominator it is 2x plus 2x is 4x is equal to m plus m is a 2m upon n plus n is a 2n. Let's cancel out the 2's from both the sides. I can factor out a 2 from here. I'll be left with x square plus 1 upon 4x is equal to m upon n. So it would be 2 times 1 and 2 times 2. So this thing can be written as x square plus 1 upon 2x is equal to m upon n. Let us take this thing to the next page. Okay, I don't have space in the next page. What do I do? Okay, I'll have to do it here. Fine. I can just I just need to report my answer, and that is like I have to report n is equal to something. So what I can do is I can send this n to the left hand side in the numerator, so it becomes n is equal to this 2x gets multiplied with the numerator on the right hand side, so it becomes 2xm, and the x square plus 1 goes to the denominator, so it is x square plus 1, and that is my final answer. So basically n in terms of x and m, so n is equal to something something, and that something only has x and m's because that is what the question says. Okay, let us move ahead to the last question of this session. Okay, this thing says if x upon a is equal to y upon b is equal to z upon c, I have to show that x cube upon a cube plus y cube upon b cube plus z cube upon c cube is equal to all of these things. Okay, let us start with the thing that I need over here. Okay, what do I need? I need x cube upon a cube plus y cube upon b cube plus z cube upon c cube. That is my left hand side. I will start with my left hand side. Okay, can I write my left hand side to be equal to x upon a the whole cube plus y upon b the whole cube plus z upon c the whole cube? Yeah, that looks really fair to me. Okay, because laws of indices obviously. Okay, now can I just say that x upon a is actually y upon b? So instead of x upon a over here, I'll write y upon b because that's what the question says. X upon a is equal to y upon b. So this thing can be written as y upon b the whole cube plus this thing is already y upon b the whole cube plus the z upon c also is equal to y upon b. So this thing can also be written as y upon b the whole cube. Now I know you must be thinking why only y upon b? Why I do not write y upon b and z upon c as x upon a? Why such partiality? No partiality, you can do whatever you feel like. Okay, because all the three are equal to each other, we'll just retain one of them and get rid of the other two. Okay, so this is y upon b the whole cube plus y upon b the whole cube plus y upon b the whole cube, which is 3 times y upon b the whole cube. So this is 3 times y upon b the whole cube. Okay, now I need a 3 in the answer. Yes, I need a 3 in the answer. What do? I just write it as 3. Y cube is actually y times y times y, so I just write it as y, y and y, and b cube is actually b times b times b. Okay, see, the first y upon b can be written as x upon a because x upon a itself is equal to y upon b. So this becomes 3 and then x upon a. The second y upon b just stays as it is, and the third y upon b can be written as z upon c because y upon b itself is equal to z upon c. So this thing can become z upon c, and my final answer is 3 x y z upon a b c, and that is what is asked in the question. That is it for this session. I hope you all understood this thing, and I would like to remind you again that the notes of all of these are in the description, and that is it. Thank you so much.